Yeah. So.
Then we're all good. You can start.
Hello. Nice to meet you. I'm Sangwook from South Korea, KAIST, and now I'm advised by the In16 and collaborating with Toby Lee in this summer. And today I'll talk about my research experience about leveraging NLP in practice. Actually, the title is so general, but I think this title is good to represent my researches. So let's begin. So this is the index, so I will introduce my research journey first very shortly. And also I will introduce the previous study. Actually that is not relevant to the studies in DGP items. So I will briefly introduce my research and then also the current study, maybe it is much more relevant and interesting to you. So I will introduce the research method in it because I'm in progress to do this study. So this is not the result, just the practice with the LMM right now. So, and then also I'll introduce some future direction for my PhD because I'm the master student and I will apply PhD this fall, of course in University of Toronto. So yeah, so I will introduce some topics for the statement of purpose in my document. So let's begin. So my research journey in HCI field starts with the KAIST 2016. So at the time I was an undergraduate student and I just submitted the poster to the student design competition, but it was surprisingly it was accepted even though that is the first time to submit some paper or poster. So I visited San Jose to present our work. So that was my beginning of my HCI research. And also in KAIST 2016, I met some researchers in HCI field, including Hyung Jung and Junan Lee in the Seoul National University. So we collaborated and we brought some poster in other conference. And then now I recently presented my paper in KAIST 2023, which is the collaboration with Juho Kim and Jin-Young Song in the KAIST. So it was the result of 1 year long internship. So, and then right now I'm doing the master's degree advised by In16 and I'm collaborating with the Toby Lee right now this summer. So I will introduce the research in the KAIST 2023 and the collaboration with Toby Lee. So luckily, this paper is co-first authored by the Jin-Young Song and me, and also so we wrote together. Actually, I did a lot in the research part, and she helped me to write the paper a lot. So, so this is the paper that is presented in KAIST 2023. So, paper title is More Sandbox Facilitating Online Community Moderation Through Error Prediction and Improvement of Automated Rules. I will show you briefly. So I'll introduce some background about this research. First, there are so many online communities managed by some volunteer moderators. And also they are using the moderation tool for automating their works. So like this, Reddit has the auto moderator, and some Facebook groups has some admin assist tool, and the servers has some moderator, which is the bot for the moderation. But we focus on the errors in the automated moderation, like false positive and false negatives. So if the robot or if the automated tool catch some post that is not intended from the moderator, human moderator, then we call it false positive, and in opposite we call it false negative. So we found some challenges through the interview with 5 Reddit moderators, which is expert users in auto moderator, which is the bot for automated moderation in Reddit. So we got some challenges in the 2 stages, error identification and rule updates, and I will show you some system I designed. So actually, it is right now. This is the basic system I used in the experiment, but this is the reflection of the current moderation process. So as you can see, there is some moderators now just see the whole post, just monitor them, and then they just see some reported post here, and then make some rules based on their memory and some experience. So make some rule and then save. Then it reflects to the post after they deploy that rule. But that is very inconvenient, right? So we made some tools to simulate the tools working, and also we add some feature to find the errors effectively using some NLP models. It's very simple, so I will introduce it. And also there is some kind of visual analysis tools to see how each rule affects to the post. So right now this rule is very complex, but we can see how each rule affects to the post using this kind of simple visualization. So this is the main whole process of the moderation. So of the using our system. So there is a sandbox, and based on the results of the sandbox, we can see some possible false positives and negatives, which is the error of the automated rules. And then using that automated rules, using the false positives and negatives, we can see some visualization about the effects of the rules, of each rule. So it can help to find some errors and then debug the rules. So and then you can see the rule updates every time. So you can check how the rules work in one single use. So I just want to highlight the some NLP used in the NLP model used in my system. So it's very simple. So this is the rule-based moderation, which is the legacy system for the moderator. And also, you know, why they use the rule-based moderation for the community moderation. Maybe it is related to the it is related to the trust about the AI. You know, if AI removes some post, then we don't know why they remove that. So they don't believe that kind of AI-based tool. So they use the rule-based tool. And also AI-based tool need a lot of resource, but they are all volunteer moderators. So they don't have money or resource to use the AI-based tool. So in this context, we just suggest some tool to find some errors using AI-based tools like NLP model. So we use it's very simple kind of embedding models for embedding sentence. So this is I use the universal sentence encoder from Google to make some embeddings for each post, and then use the target post the moderator just selected, and then just compare the similarity between the post and between the simulated result of the auto moderator. So it is kind of debugging support using the AI to use the legacy system. So this is maybe it is I think this is very effective solution for the moderators, because they can now believe that, okay, this rule is working or not. It is deterministic. But we can use some AI-based support using this kind of tool. So, oh yeah. And this is the current study with Toby Lee, and right now I'm advised by In-Sik. He gives some idea about this research. So thanks to my advisor. So yeah, so my research named Thomas, which is the task-oriented multimodal animation system. Yeah, actually I made this name with GPT-4, just ask them what is the best, you know. That is very good tool for making the system, you know, system name, yeah. So
why did you skip the U from UI?
UI, actually there's no UI here, but I added it. So actually, yeah, never mind. Maybe Tomius is not what I want, because I just use some kind of very funny how can I say it? Funny meanings inside. So yes. So that is the motivation from the research. So actually, I participate in the research about AMesh, which is the system to extract the UI from the working mobile application and made the new application from the UI from multiple application. So this was very interesting. They used some kind of legacy application and make a new interface to use that, and they how can I say, synergize the leveraging the mobile synergize its utility in one single application. And also, I saw some research from Toby Lee, which is the multimodal repairs of conversational breakdowns. So in task-oriented dialogues, it means just he made a SuHyeon, which is the system to automate some task-oriented okay, well, to do the task with the automated task automation with the mobile application, and he suggested the multimodal repair that if they made some kind of automated tool for using mobile application, maybe there is some error inside. So he just suggests the system to debug the errors from the system. So using some kind of multimodal interface, like he can use the screenshot and he can use some kind of dialogues. So, and then also I read this kind of innovative paper, yes, because this is from Brian Ma in DGP, and I'm very interested in this work because he suggests the LMM as a tool to understand the UI and make some natural language question and description from the UI. So it was very interesting to me, and also he used the HTML for AI to understand how UI works and how UI appears in the screen. So I combined 3 of research together and mixed that, and then suggest a new research. So, and then this is another motivation from the Korean government. So this is the report on digital divide. We had this kind of report, and I just found some very impressive results from here. So as you can see, accessibility to the digital device is very similar. It's almost over 95%, because in Korea, many adults already has their own smartphone. But the problem is, in the perspective of capability and practical use, is lower than any other groups like low-income farmers. I'm sorry, this is just in the perspective of the Korean government. So as you can see, it's very lower than any other groups like this. So 54%, 72%, yeah, it's very weird. And also, this is a usage rate of living service in 2022. This is very new research. So as you can see, also living information application, shopping application, banking application, public service application, they are all very low. Okay, this is the typo. Actually the whole usage of the usage rate is so low than others. So we focus on that. Why? Why they have some problem? So let's see. So and maybe there is some kind of research. I did not show this, but there is a lot of research about why they are not good at using the mobile smartphones. Actually, mobile smartphones, a smartphone has very small screen and has very complex information structure, and also they have difficulty to understanding the terms, not professional, but tech-savvy terms for the application. So, and also, so I just found another new research from the report, which is the problem-solving method for using digital device. As you can see, they are so low than general public, but only help from family is very high, higher than general public. Why? Because they are familiar with the family, and also adaptability is very important in these groups. So family members let the older adults access mobile device more easily or more in the familiar way to introduce the service. Like this is the mobile application. You can use this mobile application to do this thing, and then the conversation with family member is very important and very good for the connection, social connection. Yeah, so we focus on that. So we plan to design the Thomas, which is the grandchildren of the grandchildren agent for using the mobile device. So let's imagine the context of this. Just I'm the grandchildren, and there is a grandparents here, and I want to show you how to use them. Just not the learning, just help them to do some task with mobile application. In that case, it's better for me to use this mobile application and then have some conversation with all the others to get their objective, and then show some select options from the mobile application like this. This, what do you want to do with these options? Okay, yeah. So we made this kind of system flow, like mobile application can show you how the screens like this. Okay, it was over to 20 minutes. Oh, sorry. Oh no. We started at 10, 5, 11:05.
Oh, it's no problem.
Okay.
Yeah.
So let's see. So this is just the progress of our system. So actually, first we start with the mobile web application because it is much more easy to access. Mobile application has some privacy issue or security issue in accessing their code. But HTML or CSS, they are all open to public. So we use that raw HTML and simplify that like this. And also, it is very important for GPT because if we use the large language model to make this agent, so it's very important for GPT because they are not good at exclude some meaningless data from the HTML. So we made this kind of simplified version of HTML, and then try to let GPT understand UI using this kind of structure. So we make some kind of action element. We label some HTML tag like input, a button, and select as an action element. So this is a unit for one action, like input, click, or hover, this kind of action. And then we make the group with the action element as a unit of the feature. So based on some kind of heuristic things, like these components for the two action components, it works because they have some kind of structure, hierarchical structure in HTML, and so we can use that HTML structure hierarchy to extract some components. And then we use the system message to make some natural description of each action element and component like this. So this is the result of our agent. Like in the form, click on the input button to select the departure location from Los Angeles, CA. So we put the input action element inside the GPT and make some result based on the context of the HTML. So it is very important. So this is needed. So if you want to get some information, contextual information from the GPT, you need to give the context like this. So if you want to get some information for action elements, then you need to give some kind of contextual information from the higher level tag. So this is what I used for this. I think this is very important for techniques for using the GPT. And then based on the action element and some natural description, we plan to do some task like this. So from the chat with the target user, we extract some objective from them. And also we plan to use those action element and components using the planning inference capability of GPT. You know, they are very good at planning the task with the subtask. So we made this kind of plans. And then based on this plan, we can extract the question for the conversation. And then we can, based on the chat with the older adults, we can get some information to fill the slots for the question, answer the question. So like this. So and then we can use that question which is not answered to ask the question to the older adults. And also we use some kind of hierarchy for understanding the UI. So we can make some kind of this kind of information, which is the unanswered and answered action element. So we can make the plan for each level, and then go inside and then plan for each level recursively. So this is the example result. It's very good at making the plans based on the UI like this. So this is the natural description for action elements, and we give some objective based on the chat like this to book a bus ticket, and they make a plan for doing this task based on the UI. So we don't need to care about the planning from the ground-based from the general knowledge, because GPT has some general knowledge to do the plan. But we can give some kind of context like this, and then we can scope down the subtask like this, and then make a concrete plan for each screen. So this is what I'm trying to do. So based on the chat, this is the interaction based on the chat history. So based on the chat, we can extract the most relevant chat based on the each element's natural description using the embedding vector like this, embedding vector, and then based on that description, we can make some kind of interaction event for the action element. So like this, input Los Angeles in this action element. So, and then this is another part of our research. This is the modify UI for all the others. So this is very simple idea but very effective, like this. So if we can get some component from the focused components for the task, then we can get some HTML and CSS code from the element, and using these three methods to simplify the UI like this. So simplify each component by injecting JavaScript. So like this. So if you make some kind of component, one component has a lot of div inside, which has the similar types of the information. So we can extract some. We can get some important types of information from the chat, and then we can use that knowledge to inject to extract the important information from each component. So it can simplify the screen. And also there are some other techniques, like we can simplify the terms for each HTML tag using the GLM, because if we give them as like this, your user is the older other, or your user has some kind of contextual situation. So using that knowledge, we can simplify the terms, and also we can modify the style of the HTML tag. So we will provide the modified UI to all the others using the GPT and chat history. And I think this is very promising method to use the GPT, but it is a little bit trickier. So this is just sharing the idea for improving this system. So we can plan some how can I say? We can plan to do the task, and then based on the task, based on that plan, we can make the Thomas agent, okay? And then we can simulate the GPT as all the other edge agent. So we can simulate the conversation with the system and the older others. So based on that, we can find some failure and success to do the task. Based on that, we can use some kind of how can I say that, reinforcement learning to update the value of each plan and make it improve. We can automatically improve the quality of the agent. Okay, so I think this is very promising, but it will be very trickier, I think. So maybe this is out of scope of my research, so this is maybe future research for me. So now I will introduce some future direction of my PhD research. So actually we made some system to debug the legacy system, and using this debugging tool, we can democratization of AI governance. Like you can simulate the result of the AI-based tool. So based on the result of simulation, we can get some information from that to show the result of AI governance like this. So we can share that information to the other peer moderator who is not tech savvy, so they cannot use the auto moderator or rule-based tool. So, and also we can get some kind of board post to do the decision making about the AI governance. So I think this is very promising, but maybe after PhD begins, I can do this research. I guess maybe it will be very interesting, and also it can be extensible to any other research. Yes, And also, this is maybe for the statement of purpose by SOP, I think. So actually, I want to make a system I want to make a AI-powered